Separation of duties. The Junos operating system is architected such that its functions are divided into three logical components called planes. They are the control plane, the data plane, and the services plane. When I refer to the data plane, you can also assume that means the forwarding plane. That is, they're synonymous. The control plane is the component that manages the operation of the device that it's installed on. It also fulfills another key role by managing the other planes. The routing engine, which is either a separate physical module altogether or incorporated as part of the device, is where the control plane runs. Just a little more about the routing engine. Some devices are designed with routing engine cards, which are hot swappable physical units in the chassis. There are also options to deploy a routing engine backup, which serves as a redundant routing engine. Resilience and high availability, after all, are key components of Juniper products. It's important to understand and take away from this that by virtue of this architecture, the control plane gets a comprehensive view of the hardware and software infrastructure that it's running on. And as part of this paradigm, the control plane is also responsible for providing the user interface and is also in control of the native features of the Junos operating system. So what does this mean? Well, diving a little deeper, the implication is that all these components run on the control plane. The core of the Junos operating system, that's the Junos kernel, the different modules or daemons, and any native utilities or transitory applications or tools. In fact, taken as a whole, these components comprise what we term the Junos operating system platform. Any specific applications or user interface elements designed for the control plane are developed by Juniper Networks using the Junos Software Development Kit APIs. Those applications join the common platform, so they become part of the Junos operating system software package. The data or forwarding plane runs on the packet forwarding engine, and actually, depending on where you're reading it, it is sometimes considered the packet forwarding engine itself. It can be considered the central processing element, and it moves packets in and out of the device, think ASIC or FPGA specific hardware, for moving packets around as quickly and efficiently as possible. Now, although the forwarding plane and the control plane are separate, they do talk to each other. And one of the things that goes on in the dialogue between the two is the synchronization of the forwarding table. The forwarding table is created on the control plane. The forwarding plane gets a local copy, and the forwarding table is then synchronized with the source. The forwarding table itself contains information like outgoing interfaces and addresses. Based on this architecture, the packet forwarding engine, which again is the forwarding plane, can forward packets even during a disruption, even for example if there was a router interruption. Alright, so that's great. Just one more thing. You can consider the services plane as part of the forwarding plane in that it implements services like stateless firewall, filters, class of service, and quality of service on the packets that it encounters. So in this video, you had a look at the separation of duties in the Junos operating system architecture.